I was recently talking with some friends about determining the size of the Earth. Implicitly, a lot of people think the Earth is round. How do you prove this? I got a video right here. Check this out. I proved the Earth is... I didn't prove. It's a calculation. Who knows if the Earth is round? You know what I'm saying? But here we have an experiment where if you have two pieces of data, you can calculate the circumference of the Earth, and from that you can get the radius, and implicitly you think the Earth is round. So it's kind of like a proof about the Earth being round, being a sphere, because you got to assume the Earth is a sphere for this to work out. Today I'm going to talk to you guys about a high-level overview. If you want to see me do this calculation, I'm going to try to do it, but right now we're just going to try to explain how this experiment works and how you'd get the answer if you had this piece of info. So here's the setup. We got the sun and we got the Earth. We assume the Earth is round, having a radius r and circumference c. It's a sphere, but this cross section shows it as a circle. At one point on the Earth, we set up a post, like just a stick in the ground, and the sun, when it shines overhead, there's going to be one special part of the day, like let's say noon, where the sun is directly above this post and it creates no shadow. Maybe depending on the time of the year, like the equinox or something like this, it will create a shadow. But if you find a special point on the Earth and you pick a special time in the day, probably around noon, this sun will create no shadow on this post. At that same moment in time, you need to go a distance x across the arc of the Earth here and set up another post. And this x you need to know, so you can either walk and track the distance here, or you can use Google Maps or something. I don't know how we're gonna do it. And set up a post there. That post, at the moment in time, this thing creates no shadow. This post will create a shadow, right? Because we're assuming this little arc here. So the sun is gonna go boom, boom, make a little shadow right here. And if you know the length of this shadow and you know the length of this post, you can do some trigonometry, get theta, and this theta will give you this. I think this theta is related to this little arc of the Earth right here, this arc, this little pi wedge. So if you know this, you can make a ratio with this and 360 degrees and make a ratio with this x and c, the circumference of the Earth. And I think with those two pieces of info, if you have x and you have theta, you can find c and then you can find r. So it's not directly a proof of the Earth, but you use the Earth being round, being a sphere, as a piece of this solution. So if we run in this experiment, we get this. I don't know, somehow somebody has to validate the size of the Earth, but this experiment right now, I think will only work if we assume the Earth is round. So it's kind of like a proof of the Earth being round. Let me know if this makes sense. Let me know if you spot any errors with this or if you have any ideas. We're going to try to perform this in real life and then calculate it and see if it makes sense. And we can also double check it with this video over here, which is another method I use to calculate the radius of the Earth. We're going to see if both of those are right, and we're going to see how far those are from the actual answer. Peace out, guys. Thanks for watching.